A proper introduction. Once again, we're going to build another machine. It's once again a very intermediate build, so hopefully you know the basics. I may cover the basics in a future episode. Wow, this background much better. So we're going to build a laser alignment system for drones that needs to land plastic beams, because you can actually control the density and the color, but the density is more important. You could make it super light or super heavy, it's up to you. So the plan of this laser guided thing is laser down here, and it's going, and depending on the location of this beam, the laser would also move. So if the laser is here, the the aircraft must correct itself by moving to the left, and once it corrects itself, it corrects itself once again until it's dead straight on. So that's a plan anyway. Now when you're working on a aircraft of any sort, you want it to be symmetrical as possible. I've locked this one so that if I have a component and tries to move the main ship itself, the ship won't move because this one is already locked. Only this one can move, and oh my, that's not good. There you go. So at the sides we're going to add rocket. Now we need the propulsion systems, and yeah, the propulsion systems and the uh, logic system. That's all we need now. So we need a rocket, a rocket. So I'm going to do my standard mm, standard home the my standard the standard hovercraft that I know, where you place a tilt meter and connect them to the rockets, but usually I like to add proximity sensors to make proximity. Now each rocket is going to be connected to two if gates, if select gate, in an if select, and because this is a hovercraft, we're going to build a tilt meter. We're going to add tilt meter over here. The proximity sensor of my phone is quite digital. It's either there's something close to the phone or there's nothing close to the phone. That's it. It's digital. And in the proximity sensor of Principia, it's analog. It could be it's quite far, it's quite near, it's really far, it's really near, stuff like that. So we're adding a ceiling, which I quote from his description: anything that, wait, is it really what it says in the description? But anything that is not equal to 0 is going to be equal to 1, and that's going to go straight to input 2 of the if select. So if there's a signal from proximity sensor, it's going to use the signal from the proximity sensor. I'm recording, sorry. I'm recording. I'm recording. I'm recording. I'm recording. I'm recording. I'm recording. Close the door, please. So, where was I? Oh yeah, the proximity sensor, the signal from the proximity sensor goes to the Y splitter to the ceiling, and the one that splits off to the ceiling goes to input 2, so that whenever a tiny bit of signal comes from the proximity sensor, it's going to, the output of the rocket would go straight to the It would come straight from the proximity sensors. And now we have a basic hovercraft system which likes to bounce up and down. Hilarious. This is not good. I think we need to rewire this a tiny bit. So this one goes from to the ceiling, and this one goes to there. I want this one to be here, go there. The input to be the, and then make it so that the input from the proximity sensor goes directly to the ceiling. The sail. The sail? How do you pronounce that? I always thought this was a ceiling because there's a floor. How do you actually pronounce this? The sail? The sail? Sorry, Bithak, if I can't pronounce your component properly, but I haven't read it. Sorry, Bithak. And if this is a real world equipment, well, sorry to those electricians whose ears are unhappy. See, it's better. It seems to be better. Maybe we reduce the thrust over here. Better, not better. Oh yeah, I forgot. I almost forgot. I do not know how you're supposed to build a hovercraft system without a stabilizer. It's number one rule, guys. If you build anything, a hovercraft, so there you go. It's kind of bouncy. There you go. Not quite enough linear damping. How did we do this last time again? There you go. Finally. Not quite enough linear damping. Maybe maximum linear damping. Good. That seems good. Now we're going to do the most important thing of the build, and that is, well, we have created a hovercraft system over here, but that's not the end goal. The end goal is to build a landing system, and since it's laser guided, just add laser. As why not? It's laser guided. So we need it so that we're not going to put anything in input 1. Actually, I should have placed, instead of an if select, I think an if gate will do well for this job, but they do the same thing, but if gate's just smaller. So what we're going to do is, once this thing is activated, I mean, once the laser sensor detects a laser, it's going to, what do you call that, turn off the rockets, so the hovercraft would slowly land back to the ground. That's the plan anyways. So if the laser is on the left side, it needs to go to the left. Therefore we need propulsion systems that moves it from side to side. That's what we need. Exactly what we need. Thrusters, the smaller miniature version of the rockets. Actually, the rockets are the larger version of the thruster, because in the prequel game Principia apparatus, there were no rockets, just thrusters. Trust me. So if the signal is coming from there, it's going to go here. If the signal is coming here, and hopefully this works. Yay, it works, except it didn't work. Wonder why. So I guess it works then. So we put landing pads over here. Then yeah, it works. first try, not really first try because I've already done a prototype of this a year ago or something, when it was one of my failed videos. But it works, folks, ladies and gents, it works. Yes. Now we're going to make it so that the hovercraft is actually controllable. These guys needs to be an if select this time, and I think really need to don't think an if gate would make it smaller, but these guys needs to be if select. Wait, no, they do not need to be if selects. How silly of me. They need to be connected to an if select, not become an if select. So we're going to add a RC basic for our basic controls. Maybe anything larger than a city mini would do, but there's really no choice on the city basic. It's the next step to the IRC micro. The IRC-IO3 is has only 3 inputs and outputs, but it's way smaller than the RC basic. Input 0 goes to the left and input 1 goes to the right, and we need landing system activate at input 2. Now we've done that. Certainly this guy needs to go through a AND gate. The input of that thing needs to go to AND gate. Now why am I splitting this again? Oh yeah, this thing needs to go to an AND gate. I just said it. Now we need another Y splitter that splits everything between everything. Mainly just the two of the things. Over here. I mean, it wouldn't need to be an if select if we do not have input for input 2. That's the most important thing in the if select. I'm going to attempt to make this thing as level as possible. Probably going to fail miserably, but there's no harm in trying, I guess. There you go, we now have our landing system. Now we go here. As you can see, we have control over the spacecraft thing. Then we go here. See, we have absolute control, and when we need to land, just turn off this thing. Just make sure that this thing is on the platform and we land. Feels like it has wheels in the way it moves around. Like, dude, look. If I go to a higher elevation, it feels like it's climbing something. And it is, because it's a characteristics of the proximity sensor. So now if we need to land somewhere really really tight, you just press this, boom, land. It works. I think that's all that matters. So see you guys next time. Wait, no, before we do anything else, save. There you go, we now have this thing. This is done. So hope you enjoyed this video. See you guys in the next build. Peace out.